So you and I are
Hmm.
young,
Yes.
and this technology can be applied throughout our lifetimes, but someone who's older is going to miss out on this, right?
It can be, yes, because of their organism. Their organism is not like such metabolic advance as ours. Your metabolism like slows over the course of the years, right?
Yeah.
And right now we're in a really young age where we have our metabolism at the top, and I think it will be easier for us to adapt if we were inserted to CRISPR than for people who are already like 83 years old. Plus, once you like get older and older and older, there's gonna be like more mutations in your DNA, which actually can trigger cancer. It can trigger such a bunch of stuff, to be honest.
Wait, say that again. So as you get older,
As you get older, you are more susceptible to get like, for example, cancer and other diseases, right?
okay,
It's
that makes
because like
sense.
when it's because like also your organism like is gonna confront mutations, and those mutations are actually gonna, maybe you have cancer or maybe Alzheimer's disease or another kind of disorders.
So, so young people right now, this technology comes out. It looks like it looks like we can live healthier as we get older, right?
Yes.
With some of these things. And that's exciting for us, right?
Hmm.
That's pretty cool. What about someone who's a toddler right now? Like, what will this mean for them in their lifetime?
For people who are like older,
Toddler, like 2, 3 years old.
actually that's where it comes like the main like point in bioethics as well, is because like let's say something who is like just a newborn, or between the first 5 years of their life, right? Let's say they got Down syndrome, right? They
Mm-hmm.
can use CRISPR to actually knock out the gene of which causes Down syndrome, and they can live a pretty normal life.
This is what'd you say the cutoff was?
Oh, to
Or
cut off the gene that causes Down syndrome, and after that, they can have a pretty normal life.
but like at what this can happen at any age potentially.
I'm not 100% sure, to be honest, but most of the research are actually trying to focus on like newborns, just because of that, because like their metabolism is still young and their organism is still young, so they have their whole lifetime to develop.
That's what I'm curious about. Like on the scale, we now have this gene editing ability
Yes.
on this like human life cycle scale right now as it sits. Like you and I are fairly young. We're leaning towards the younger part of the scale. Um, is it like, do you have to the closer you are to being a newborn, the easier in your lifetime it will be to apply this stuff?
The easier it gets, yes.
Right. I guess so. My question with this is, did we miss out? Are we part of it still, or are we like right in a great spot
I
for the
think we
future?
are just in a great spot, to be honest, because like
Okay.
we're still young, we have like a whole life ahead of us.
Yeah.
So I think it's still possible for people of our age to apply it.
Do you feel like the technology, the biotechnology of CRISPR will get better and better and better as far as like,
Most definitely, yes.
why do you feel things like this in biotechnology will be um, common in our lifetime?
You mean like in the future?
Yeah.
Because like nowadays, like we have people trying to look up for solutions for everything. So I'm pretty sure that this field is gonna increase over the next years. To be honest, there's a high demand when it comes to people who know how to handle these mechanisms.
And they're going to want to teach more and more people how to do this stuff.
Exactly. And my prediction for this is just like over the next 10 or 20 years, this technology is just gonna grow exponentially.